Good day. Today we are going to discuss logarithmic equation. Now we are going to solve logarithmic equation, determining the solution set of the given logarithmic equation using the laws and its properties. Okay, so let's have an example. So determine the solution set of the given logarithmic equation. 10 plus log of the quantity 6x minus 10 with base 9 equals 13. Now, the solving of a logarithmic equation is somewhat similar to solving uh, algebraic expression. However, we have to take note the logarithmic properties and laws of logarithm. Okay, in this case, our goal is to have a single logarithmic expression in one side. So what we're going to do is we're going to, the 10 will be removed here. So to remove the number 10 here, we have to subtract both sides by 10. So we subtract 10 here and we have to subtract 10 here. So in other words, we have the logarithmic or logarithm of the quantity 6x minus 10 with base 9 equals, of course, 13 minus 10 is equal to 3. Now, since we have a single logarithm in the left side, then we can now use the properties of logarithm or the laws of logarithm. So we have, okay, because this is the base, okay, this is the base, this is the exponent, and this is the answer. The argument of the logarithm is actually the answer of the exponential equation. Okay, so you have 9 raised to 3 is equal to 6x minus 10. And then 9 raised to 3 is equal to 729, and then that is equal to 6x minus 10. So since we have only to get the value of our x, then we have to add both sides by 10 to make this one 0. So you have 729 plus 10 is equal to 6x minus 10 plus 10. So this will become 0. Then we have 739 equals 6x. Then we have to divide both sides by 6. Then we have 739 over 6 is the value of our x. Now, we cannot be sure that this is the value of our x. We have to do the checking. So we have to check at x is equal to 739 over 6. Now, the 739 over 6 will be substituted to our logarithmic equation. So that would be the original logarithmic equation, substitute. So the x will be substituted by 739 over 6. Okay, so we have to, since there is a common 6 and 6 in the denominator, then we can now divide it out. Okay, so we have this one. And 739 minus 10, of course, is equal to 729. The 729 can be rewritten as 9 cubed. Okay, 9 cubed. And, okay, using the properties of logarithm, okay, the exponent within the argument will become the factor of the logarithmic expression. So, in this case, we have 10 plus 3 logarithm of 9 with base 9 equals 13. Since in this side, as we can see here, the argument and the base of the logarithm is the same, and if that happens, if the argument and the base are the same, then that is equal to 1. So you have 10 plus 3 times 1 equals 13. That is equal to 13 and the left side and both sides are now equal. Therefore, we could say that the value of our x in the given logarithmic equation is 739 over 6. Let's have another example. Let's say 2 log of the quantity negative 10x minus 8 with base 6 equals 0. Okay, now what we are going to do here is that we have to make this 2 before the logarithm as the exponent of our argument. Since we have this one, then we can now make this equation. We can transform this logarithmic equation into exponential equation. So you have 6 raised to 0 is equal to the squared quantity of negative 10x minus 8. Okay, since we have here 0, so this will become the exponent. And 6 raised to 0 is equal to 1. And then, since this is squared, we can now multiply the negative 10x minus 8 to itself. So you have 100x squared plus 160x plus 64. Since we have 1 here, we can subtract both sides by 1. So we have this one. Okay. And then, of course, 1 minus 1 is equal to 0. For this case, I transfer this right portion, right side of the equation to the left side, and the left side is transferred to the right side. They are just the same. Okay. Then, since the right side is equal to 0, then we can now make this one as a factor. We can actually get the factor of 100x squared plus 160x plus 63. So the factors are the quantity 10x plus 7 and 10x plus 9. Now, if we have, remember in the solving equations, if it is in factored form and then it's equal to 0, then we can set the one of its factors is equal to 0. Okay, so in this case, on this side, this could be the value of x here could be negative 7 over 10. And here, we have negative 9 over 10. So that's the value of our x. These are the possible values of x. Okay, possible, it's because we have to do the checking if they are really the solution of the logarithmic equation. Okay, so let's try to check at negative 7 over 10. So substitute the negative 7 over 10 to the x, okay, in our original logarithmic equation. And since we have here, look at it, this is the x. Okay, the negative 7 over 10 is actually this one, the x. Then we can now, okay, simplify. But first, since we have here negative and they have negative, these can be cancel. This becomes positive. And of course, we have 10 and 10 in the denominator. So we can now divide out. That becomes 7 minus 8. Okay. And we have that one. Now remember that in our previous discussions, the argument should be positive numbers. Okay, positive numbers. So in other words, since we have an argument of negative 1, then this is not possible. So negative 7 over 10 is not a possible solution set of the logarithmic equation, because if we have negative 7 over 10, the argument becomes negative. Now, let's try negative 9 over 10. Okay, so substitute the same process. Okay, so what remains is we have 2 times logarithm of 9, the quantity 9 minus 8, with base 6. Is that equal to 0? 9 minus 8 is equal to 1. And from the previous discussions, if the argument of the logarithm is 1, that is automatic equal to 0. Okay, so 2 times 0 is equal to 0. So since only the negative 9 over 10 can satisfy the logarithmic equation, therefore, our solution set of the logarithmic equation is negative 9 over 10. The negative 7 over 10 cannot be the solution of the logarithmic equation. So let's have another example. So let's have 6 times the logarithm of the quantity 9x plus 7 with base 4 equals 0. Okay, so similar to what we did on the previous slide, we are going to make the 6 here as the exponent of our in our given argument. Okay, and we can now have like this. So 4 raised to 0 is equal to 1, and we can actually extract, okay, since here we have the exponent is 6, then we could we can actually extract the 6th root of both sides. So we have 1 equals 9x plus 7. And, okay, since we have 1 equals 9x plus 7, we can actually, okay, so what I did here is to make x on the, to make x transfer to the left side. So that's why I subtract both sides by I subtract both sides by 9x. And then I want this 1 to be transferred on the right side. So I subtract both sides again by positive 1. So that's why we have 1 minus 9x minus 1 equals 9x plus 7 minus 9x minus 1. Okay, so 1 minus 1 is equal to, okay, by the way, so here, okay, I have some minor correction here. So here, what I did is that I subtract both sides by 7. Okay, so that's it, 7. Okay, so we have negative 6 equals 9x. And then we have to divide both sides by 9. So we have negative 6 over 9. And then reduce the lowest term. Then we have negative 2 over 3 is our value of x. But this is not yet the confirmed value of x. We have to do the checking at x equals negative 2 over 3. Now, we have to substitute the negative 2 over 3 in our given x in our given logarithmic equation. So that's it, the original equation. Substitute the negative 2 over 3. So that's it. And then, of course, the 9 divided by 3 is equal to 3. Right? Then 3 times 2 times negative 2, that's equal to negative 6. So I repeat, 9 divided by 3 is equal to 3 times negative 2, that's equal to negative 6, plus 7, okay, so that's it. The negative 6 plus 7, of course, is equal to 1. And then, if the argument is equal to 1, then we could say that the logarithm is equal to 0. So 6 times 0 equals 0, and 0 equals 0. Therefore, the value of our x is negative 2 over 3. Let's have the last example. So the logarithm of the quantity x plus 4 with base 5 plus the logarithm of x with base 5 equals 1. As you can see here, there are two logarithms in the left side. So as much as possible, we have a single logarithm in uh, in one side. So it's either right or left. Okay. So what we did here is that, okay, the since it is addition and they have the same base, then we can use the properties of logarithm that we have to multiply the arguments of the logarithm. So we have the quantity x plus 4 times x. Now, since we have this one, then we could say that we have x squared plus 4x. So the x is just being uh, distributed inside the parentheses. Then, what we did here is we transform this kind of logarithmic equation into exponential form. So 5 raised to 1 is equal to x squared plus 4x. And we have subtract both sides by 5. So we have x squared plus 4x minus 5 equals 0. What I did here is that this left side is transferred to the right side and the right side is transferred to the left side. They are just the same. Now, we can say x squared plus 4x minus 5 is equal to 0. We cannot factor out this one. So, the factors are the quantity x plus 4 and x minus 1. And then, we set one of its factors is equal to 0. If x plus 4 is equal to 0, then our x is equal to negative 4. Now, in this side, in this factor, if x minus 1 is equal to negative, if x minus 1 is equal to 0, then our x is equal to positive 1. Therefore, there are two possible values of x. We have negative 4 and 1. Now, let's try to check at x equals negative 4. So, we have to substitute the x in our given logarithmic equation. So, that's it. I just directly substituted negative 4 in our x. And as we can see here, we have argument of 0 and negative 4. So, remember that our argument must be greater than, must be at least 1. And then, we should not have a negative argument. Therefore, negative 4 cannot satisfy the properties of logarithm. Then, negative 4 is not a solution set of our logarithmic equation. Let's try x equals 1. So, substitute. Okay. And, of course, we have this one. And that one. If the base and the arguments are the same, then that's equal to 1. If the argument is equal to 1, that's equal to 0. So 1 plus 0 equals 1. Therefore, the the solution set of the given logarithmic equation is actually positive 1. So that's it for today.